Hey students, welcome to Loksatta Yashasvi Bhava. We are going to see the next part of probability, that is the probability of an event, properties of probability, and we are going to end the lesson with the addition theorem on probability. When we come to the probability of an event, we say it as the probability of an event A of a finite sample space S will be written and denoted as P standing for probability, event A written in round brackets. That is equal to the number of sample points in event A upon the number of sample points in S, that is the sample space. So in short we write it as P brackets A is equal to N event A upon number of sample points in the sample space S. You will understand this when we consider one example, and you will also know the method of how to solve the sum related to probability. The sum says, a die is thrown. Find the probability of the events 1. Getting a number less than 3 and 2. Getting a prime number. When the sum has been given to you related on probability, you first try to understand what is the sample space. Now you must be thoroughly knowing that the sample space for one die when it is thrown would be the points 1, 2, 3, 4, 5 and 6. So write them as let S be the sample space with the points 1, 2, 3, 4, 5 and 6. Do not forget to put the curly brackets when you write the sample points. After you write the sample points, write down the number of the sample points, and so we write therefore NS is equal to 6. This was your preliminary part. Let us continue further with our sum. We have been given two events. The first event is getting a number less than 3. Write this in the form of the name of the event. So I have given here the name of the event as A, and I write the statement let A be the event of getting a number less than 3. Numbers less than 3 would obviously be 1 and 2. So I write the sample points as A is equal to brace brackets 1 and 2. Therefore the number of sample points in event A are 2. And so I get the probability of event A by writing the formula in A upon NS, that is equal to 2 upon 6. Now your duty is to write the probability in the reduced form, and so when we take the tables of 2, I write it as 1 upon 3. Now let us consider the second event. Let B be the event of getting a prime number. Students, we are knowing that prime numbers, they begin from 2 onwards. So we write the sample points as B is equal to 2, 3, 5. Again, do not forget to write the number of sample points in event B as 3. Then probability of event B, write the formula that is NB upon NS, that is again 3 upon 6. Write the reduced form, that is 1 upon 2. And always we end the sum with our final answer. Probability of event A is 1 upon 3 and probability of event B is 1 upon 2. We are going to take one more example, a little different type. Let us see the example. If a card drawn from a pack of 52 playing cards, then find the probability of getting a red card. Now children, in a pack of playing cards, we have two types of colored cards, the red cards and the black cards. So it is our first duty to write down how many red cards are there, and those would become our sample points. So we write the statement as there are 52 playing cards, hence the number of sample points would be 52. Let A be the event of getting a red card. So total red cards in our pack would be 13 diamond cards plus 13 heart cards, that is equal to 26. And so the number of sample points in event A would be 26. And then the sum becomes very simple. Once again we write the formula. Probability for event A is equal to number of sample points in event A upon number of sample points in sample space S. that is equal to 26 upon 52. Here once again, when we use the tables of 26, we get the reduced form of the fraction 26 upon 52 as 1 upon 2. And then, since this is a statement sum, our final answer is the probability of getting a red card is 1 upon 2. Once we have understood what is the probability of an event, let us quickly go through to the properties of probability. There are 3 properties of probability given. The first property says probability of an impossible event is 0. That is, probability of a null set is equal to 0. Also, probability of a certain event is 1. That is, probability of the sample space is equal to 1. If second property states, if S is a finite sample space and A is the event of S, then we say 0 less than equal to probability of event A is less than equal to 1. And the third property states, if S is the finite sample space and A is the event of S, then probability of complement of event A is equal to 1 minus probability of event A. Do not get more worried about these properties because they can be easily solved in the form of examples. Let us see one example related with the same. The example is related with 3 coins which are tossed simultaneously. We are going to find the probability of events getting no head and the events getting at the most 2 tails. When we begin with the sum, we always begin with the sample space. So we write, let S be the sample space, therefore S is equal to the 8 sample points written by inserting commas in between, written in brace brackets. The sample points are 3 heads on the 3 coins, or head, head, tail, or HTH, THH, HTT, THT, TTH, or the 3 tails on the 3 coins. So therefore the number of sample points would be 8. Let us first consider the event A of getting no head. Understand the sentence once again. The event of getting no head, it means that there should be no head on any of the upper surface of the coin. That is, the sample point in the event A would only be 3 tails on the 3 coins, and therefore we write the sample space as A is equal to T, T and T, and the number of sample points in event A is therefore 1. Once we get the number of sample points, write it in the formula of probability. Probability of event A is equal to number of sample points in event A upon number of sample points in event S, that is equal to 1 upon 8. Let us take the second event, that is, let B be the event of getting at the most 2 tails. Getting at the most 2 tails, it means there should be 2 tails maximum. So our sample points would be B is equal to 3H, HHT, HTH, THH, HTT, THT and TTH. Now, instead of going by our usual way of writing the probability, let us use the third property of probability. How are we going to use? Let us see once again. B, we know, is the complementary event of A. So we write it as B is equal to complement of event A. That is, probability of event B is the same as probability of complement of event A. And what is probability of complement of event A? That is 1 minus probability of event A. We are just going to substitute that on the right hand side. And instead of writing probability of complement of event A, we write as 1 minus probability of event A. We have just now found out the value of probability of event A, that is 1 upon 8. We substitute this value in on the right hand side and we write as 1 minus 1 upon 8. When we solve it arithmetically, we get the value as 7 upon 8. And hence we say the probability of event B using the third property of probability is 7 upon 8. Once again, do not forget to write your final answer since there are two events. Probability of event A is 1 upon 8 and probability of event B is 7 upon 8. Now we are going to understand the third part in this probability, that is the addition theorem of probability. While seeing the addition theorem of probability, we have to say if A and B are any two events of a sample space S, then probability of union of event A with B is equal to probability of event A plus probability of event B minus probability of A intersection B. Students, when you must have seen this formula, immediately you must have recollected the theorem related with the chapter 1 sets of standard 9. This is called as the addition theorem of probability. Also remember your two statements related with the theorem. The first statement says probability of the union of these two events is equal to probability of event A plus the probability of event B when A and B are mutually exclusive events. And also remember, probability of event A plus probability of event B is equal to 1 when A and B are not only mutually exclusive events but they are also exhaustive events. Students, always remember these 2 points when you use the theorem, the addition theorem of probability. Let us see how this theorem is used in these two examples. The first example is a merely substitution sum. It says A and B are two events on a sample space S such that probability of event A is 0.8, probability of event B is 0.6 and probability of union of A and B is 0.9. Then we have to find out probability of intersection of event A and B. When we begin with the sum, we have to write down once again the given part. Then we are going to write the formula, that is the addition theorem of probability, as P A union B is equal to PA plus PB minus PA intersection B. Substitute the values in the formula as they are given in the sum. And so we write 0.9 is equal to 0.8 plus 0.6 minus probability of event A intersection B. Solve it arithmetically and we get the value of the probability of intersection as 0.5. Once again, do not forget to write your final answer. The second sum says, one lottery ticket is drawn at random from a bag containing 20 tickets numbered from 1 to 20, and hence we have to find the probability that the number on the ticket drawn is either divisible by 3 or by 5. Now this may be a little longer sum to understand and solve it, but stick to the different concepts and formulas related to probability and you will score full marks when you solve the sums on probability. Let us see how the sum has been solved. Write as usual the number of sample points in the sample space S. They would be 1, 2, 3, 4 onwards till the last points 19 and 20 completed with your brace bracket. Then do not forget to write the number of sample points as 20. Now let us come to the first event, that is C, and write it as let C be the event of the number divisible by 3. Mention the sample points of C as 3, 6, 9, 12, 15 and 18, as these are the numbers divisible by 3. Write the number of sample points as NC is equal to 6. Write out the second event. D is the event of the number divisible by 5. Write the sample points as 5, 10, 15 and 20. The number of sample points would be 4 here. Now the additional part is to find the number of sample points of the intersection of these two events. And we write it in the symbolic form C intersection D contains the common element 15. and hence the number of events would be 1. Now write them in the formula of probability. That is, probability of event C is number of probability in event C upon ns, that is equal to 6 upon 20. Similarly, probability of event D is number of sample points in event D upon number of sample points in the sample space, that is equal to 4 upon 20. And also, probability of the intersection is equal to number of sample points in the intersection upon the number of sample points in the sample space, and that is 1 upon 20. Now write the formula. What formula? The addition theorem of probability, which states probability of intersection of C and D is probability of the event C plus probability of event D minus probability of intersection of C and D. And so we say probability of C union D is equal to 6 upon 20 plus 4 upon 20 minus 1 upon 20. Now, as we have seen, 20 is the common element in the denominators. We can directly add up the numerators. And so we get 6 plus 4 minus 1 in the numerator. That would give us 9 upon 20. And hence our final answer would be probability for C union D is equal to 9 upon 20. So we have seen up till now the various concepts and formulas related to probability. That is, in the first part, we dealt with the various terms of probability. Then we have seen the various events of probability. In this part, we have seen what is probability, its formula, and the addition theorem of probability. Students, if you remember certain points, this lesson is a lesson where you can score easily the full marks of the sums which are given in your board question paper. Children, please remember certain points which I have given. That is, revise this lesson from time to time, the various concepts and the formulae related to probability. Also, understand certain conditions like getting exactly 2 heads or getting at least 2 heads, which means 2 or more heads, or getting at the most 2 tails, that is 2 or less than 2. These 3 sentences are related when we toss 3 coins. Also remember certain sentences like getting the sum of the numbers on the upper face of the die is at least 10. That is, the sum of the 2 numbers on the dices should make your sum either 10, 11 or 12. Not only we should remember the sentences, but do remember your playing cards, which might be a favorite game of yours. That is, there are 4 types of playing cards. Cards with a red color, which are called as heart cards, and the diamond cards. Cards with the black color, which are called as club cards, and the spade cards. Also remember, the face cards are the king card, queen card, and jack card. Ace cards are not the face cards, and 10 number cards, of which the card bearing 1 is called as the ace cards. Why I have given you this information? Just because there are some sums in probability which are based on the pack of the well shuffled cards. So students, revise the lesson properly, score your marks easily, and do the chapter well. Once again, I would like to remember you, if you have any doubts or queries, please log on to www.loksatta.com or send your emails for the same address. Also, for more solved examples, please refer to the issue related to this lesson of Loksatta Yashasvi Bhava. Thank you.